All right. Hello, everybody. My name is Tim Stewart. I work at a company called Visual Decisions. I've been leading that for about 24 years now. One of my key partners in the industry is Sandalwood. With me today, I have Thomas Stecco, and we're going to be talking about architecting the hybrid MES, bridging the discrete manufacturing from edge to enterprise. Thomas, if you can give a quick introduction of yourself and Sandalwood, and then we'll jump into the content.
For sure. It's always good to be back. We've done a few of these in the past.
Yep.
One of my first projects in 2019 was working with you. It's been 7 years now that I've been working with Sandalwood in the systems integration group. I worked on various projects in digital transformation, IIoT, Industry 4.0, cybersecurity. As Tim mentioned about Sandalwood. So Sandalwood is an engineering ergonomics professional services firm with the goal to help you work safer and smarter. We do have offices in Canada, USA, and Mexico. And I'm currently sitting in southwestern Ontario, Canada, which is typically called the Florida of Ontario.
All right. Let's jump into it. We're going to hopefully be around 15, 20 minutes here today, and we should go pretty quick. So I'll turn it over to you.
Yeah, for sure. We just got a couple slides here. I generated some of these slides based off of past experiences that I've seen in the past, looking at specific projects in various types of industries, not just what we see in automotive or something like that. It could be pharmaceutical, it could be packaging, pulp and paper, etc. When we're looking at this one here, bridging the gap with siloed data. Most plants don't have a lack of data. It's actually, we have quite a lot of data. The problem is where that data lives. PLCs are generating a ton of data. We have machine states, production counts, faults, but all that data is typically trapped inside of that SCADA system. And at the same time, we have ERP systems or platforms that are relying on data that might be coming from Excel or some sort of third-party reporting systems. And what happens is we get a disconnect between what's happening on the floor and what the business actually sees. So what the operators might be seeing or what the supervisors might be seeing is one thing, but without having that enriched data, we lose key performance indicators on our KPIs, availability, OEE, performance, and etc. And typically with this type of architecture that we see, we're typically working blind, right? And it's very, very difficult to continue to develop if scaling is a particular question.
Okay.
So siloed systems, we quite see this quite a bit if we have generational type of manufacturing processes. So if you look at this particular stack, each system is built with a specific purpose. So your SCADA system is built for monitoring, your MES is built for execution, and your ERP is built for planning. But the problem is each of these systems is built on its own model, and they interpret that data their own specific way. Over time, what I've seen and what I still currently see is we have teams that start to connect these systems together to solve problems on the fly quickly, where we might add one method or we might add a custom property or a custom application here and there. Initially, everything works fine, but as your environment grows, your integrations become harder to manage, scale, and maintain. And depending on how many developers you have or any backups that you might have or you might not have, it's very, very difficult to scale this type of application when all of your data is coming from third-party sources and not everything is unified within a unified data model. So this is typically what I see. And it's always a matter of proper planning to make sure that even before a project is rolled out, we have a clear plan, a clear definition of what means what.
Yep. And I mean, this is very common infrastructure for different manufacturers, right? You've got that SCADA layer to connect and collect the information from the different systems. That integration to the MES layer for that execution and kind of persistence of information, and then the ERP business layer within the organizations. And so, very common set of infrastructure here.
Yep, yep. Very common set of infrastructure, and we have few people in a few departments that are experts on those type of systems, or know how to run those methods, or how to do those API calls, right? And they're specifically knowledge on those specific tasks, right? And that's what they only know. It's very hard to take that knowledge and integrate that into some sort of a third-party mainframe that can be our digital backbone, as we call it here. So
Yep.
what is a hybrid MES? It's not really a product. It's not something that you can go out and buy. It's really a method of bringing all these different layers together, defining our operation. So we typically have our edge intelligence layer. That's our machine data coming from our PLCs, our TUs, our control systems, etc. The big thing here is the integration layer. This is what connects everything and consumes our data. It gives us value based off of our data. Data is data. It's boring, but if we can transform that data, normalize that data, visualize that data, make actionable decisions based off of that data, uh, it plays a huge role in our ability to maintain a proper production structure. So the goal here is not to rip and replace what you already have. It's really to connect those systems in a way that they communicate together. So instead of forcing everything into one platform where you can create a lot of bottlenecks, we just create this typical ecosystem where each layer has its own specific role. If we go to the next slide, I kind of have a little, yeah, exactly here. We broke this down in the last slide with the four pillars. We have the edge, we have the enterprise, the operations layer, and everything is kind of fed into that integration data platform framework here, right? So the data flows into each layer and it's processed right in that middle integration platform. And that could be our ignition, that can be our PTC, it could be our ThingWorks, it could be any type of program that can accept data from all these different tags, all these different PLCs, all these different ERP systems. And the specific separation allows that hybrid model to scale and remain flexible over time, right? And as long as each layer does its job, the data flows in a structured way. We don't have any issues with throttling or any issues with missed reports. Everything is functional within this entire ecosystem here. And the more and more we tackle these newer projects, I mentioned planning. Planning is extremely important even before we start mapping states or trying to figure out what a blocked fault is. Is that an active fault tag that's true within that PLC? Even before we look at all that, we really need to dumb it down a little bit and try to see where the data is coming from, what we can cut, what we can integrate, and how we can push this to be a repeatable model for additional plans, additional lines, and additional services moving forward.
Yep. And for the people that don't know, Ignition, ThingWorks, Tulip are different platforms that provide a certain level of functionality out of the box, but then you can extend that functionality by building modules on top of that platform that perform different tasks and so forth. And so rather than, for instance, working with a traditional MES application, Wonderware, et cetera, these are things that allow you to, kind of build the functionality that you require as opposed to just getting whatever comes out of the box.
Mm-hmm. Mm-hmm. Yeah, correct. If we can push the slide 6 here, Tim. The
Yep.
integration layer is a layer that we're just discussing here, right? So every uh, IIoT framework has its pros and cons. To mention ignition by inductive automation, we have PTC ThingWorks, we have Tulip, we have Power BI. There's many applications out there. It just depends on what specific API calls, drivers you might need, what type of machines you need to connect, what type of data you need to interconnect, and what the platform specifically allows, right? We're also handling APIs and system to system communication. The most important concept here is decoupling. Instead of connecting machines directly to our ERP and MES systems, everything flows into our framework here. And once we have all that data, bunch of ones, a bunch of zeros, a bunch of tags, so we can normalize that data, transform that data, we can visualize that data with specific dashboards, so we can have pop-ups being generated on a production screen if a SPC tolerance variable is plus or minus 3 sigma. If we're looking at specific tolerances, we can have the system be actionable, alerting us and giving us valuable data that we couldn't have before. One thing that I noticed specifically in this type of environment is production counts, where you have line one that might have a station called pay point or something like that, where that station counts your total good parts or your total bad parts. You might have a similar station with a similar type of architecture, but might have a different way of counting parts. So it's very difficult to have a method for line A and line B that might be unique or very similar, and to scale that to other plants, right? And this is kind of a big deal when we're trying to look at the entire process, not to really rework the entire architecture.
Yep.
Hmm. So one of the biggest I see is systems that disagree with meaning. What I might call downtime might be different from what you call downtime, Tim, right?
Right.
Um, Machine states can be defined completely differently. We have blocked, we might have starved, many different type of meanings and many different ways to map those to our PLC tags. So even though if our data is connected, it's not consistent. So the takeaway from this type of approach is having that unified data model is just as important as the architecture. If we're not speaking the same language, our KPIs will never line up. If we have a portal or some sort of a gateway that's doing reports on X amount of plants, everything has to be the same, pretty close to the same for those reports to push, right? And this is all based on those specific definitions.
All right.
I mentioned the machine states. One of our first projects, Tim, if you remember, is we needed to define machine states on some machines. And it took us a while, speaking with maintenance, controls, to try to really iron out the starved mean auto mode is true and X is false and X is false. But if this is true, then proceed with calling this state blocked or starved. It took us time to go through all those parameters, but once we had everything defined and we analyzed those workflows, we started getting actionable data on those charts. We started getting data on power, torque, current, right? And it all of a sudden now we were showing, hey, now that we have the machine states figured out, now we can do shift schedules. Now we know it's not a break, it's downtime. Now this is calculated for our KPI calculation. Right? So standardizing machine states, again, it might sound basic. It's something that really needs to be thought of across all your different types of machines.
Yeah, and that's particularly true when you're building it off of multiple signals like this. You may
Mm-hmm.
have a power draw, you may have whether a spindle is spinning or not, and You're looking at combinations of different things to determine what that state actually looks like.
Yeah, 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 yeah. And once you define those states and you put those methods into practice, your data starts flowing quite fast. You start getting actionable results quite fast. And now, what do you do with that data? This leads me to my next slide here is, well, it's like metadata when you take a picture with your phone. If you take a picture with your phone and you go to the properties, you can see a lot more than just the name of the photo. You can get the metadata. If we have a part that's being produced and we have a cycle and we have a time, we have maybe a batch number, serial number, QR code, RFID tag number, roll number, etc. We can use that data to really drive our business insights where we can log that data in a historian to use it for reports. We can use that data to analyze charts, to show rich charts with SPC variables, or we can show some heat maps or some sort of charts that we can show how well your system is performing on a specific shift. Data is boring. If I just see a value of 12.1, what does that mean to me? What does that mean to the operator? But if that number is doing something in the background, that something is being calculated and compared to, and an alert pops up on my dashboard to tell me, oh, overcycle or gearbox temperature oil high, blah, 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 blah. It gives me some confidence in the actual system that the system is performing well and that the data is actually being utilized correctly.
Right. That context means everything.
Oh yeah, yeah, for sure. You have the data. The data is there. Your SQL database, your relational database is full of data. It's how do we use that data, right?
Yep.
Yep.
Oh, hey, that was a good segue.
Exactly, right? One of our first projects, we kind of had this basic data, right? And then once we started extracting tags out of the PLC and creating think shapes as an example or some sort of templates, we were able to then, okay, this type of machine has the following properties. It has part number, um, voltage, batch number, and everything is defined in a template. So I know when a new machine is added, I can have a method that automatically builds that machine on my display. And now I can show part number, temperature, whatever data I have available. And then if I want a custom report that I need to send to the engineering department based off of the last 6 months of data for a specific SPC variable to see if maybe the gearbox in this robot doesn't need to be changed every 6 months. The manufacturer says it needs to be changed every 6 months, but the data looks like it could last maybe 9 months, right? So we can save money on preventative maintenance. Having this type of data is huge in our every day-to-day life.
Yep.
Yep. The biggest challenges I see is scaling. It's relatively easy to build an application like, let's say we need to create a little dashboard to monitor some production application or create a tool to store work instructions, point things out. When you try to roll this out across multiple plants, multiple lines, things typically break. And then you end up with one-off integrations, unique data models with no unique rollout. So the key fundamental thing I want to address with a hybrid MES solution is focusing on repeatability. One cool thing we were talking about was one cool thing about Ignition as an example. I can build a template repeater with a couple custom properties. So let's say if I have one machine on my PLC and I have it mapped on a dashboard, if a new machine is added and now I have a script that checks to see how many items are in a table, if I see that there's another one, I can automatically build another one of those machines on my dashboard without doing anything.
Right.
Right. It's just a matter of scaling and what we plan on doing with the future. We can always start small, start with one line, one small little department, one concept, and see if we can replicate that concept, come out with a rollout strategy, right? And I've seen if we've planned, if we've had meetings to discuss meetings, and everyone is on the same page, we'll typically execute just fine.
Yep.
Yeah.
All right. Final
Not
thoughts?
too bad. 21 minutes.
Well, for me, it was a really good presentation. We went through it pretty quickly, but it shows what you can do when you take this kind of more modular approach to putting this together rather than dealing with some of the monolithic MES type of applications.
Yeah, like
That,
when we put all these things together, that's where we really get the real-time visibility into the business logic, right? And then we can get those KPIs, and then we can look at the ROI, right? And see what's meaningful, what's valuable, what's really making sense.
yep. All right. Well, thank you very much for your time today.
Yeah, no
Always
worries, Ken.
appreciate having you on here.
Yeah.
Look forward to the next time that we get together and talk about all this stuff.
All right. Thanks again, Tim. Have yourself a great night. Thank you.
All right, you too. Bye.